देश में। तो मैं आपकी करतल ध्वनियों के बीच आमंत्रित करता हूं हमारे निदेशक को कि अपने वक्तव्य से हम सभी को समृद्ध करें। हमारे बीच हमारे कुछ विदेशी मेहमान भी हैं, मैं उनका हार्दिक स्वागत करता हूं। वेलकम।
Good morning to all of you, Deputy Director, the Dean R&D, and other deans and faculty members. It's very unfortunate that my friends, student friends, have just left, or in fact they have not come. It's really a very unfortunate thing. You must have heard the Prime Minister. In fact, one should have a vision. You have seen that 1962 it was thought of, and what was missing is willpower. The same thing is missing in this institute for the last 72 years. I can tell you that the feeling that we have, that we are enough, we don't need anything, we know much more than others, is absolutely a wrong feeling. One must think that you will be in the top 10 in the world. You have to think. You have to visualize. I think my friends feel that there is no need of such a thing. I think we have given half a day off for the classes, so the students will be here, the faculty will be here. We have 800 faculty. Friends, they must know that this institute is not only on few of the people who feel that this institute can run. They will realize, and they have realized. You have seen that what we require today and what we have. Many of you do not know that most of the people, the maximum number of people in this country in IIT system who are working in AI belong to this IIT. It is very, very important for us to take this mission ahead. The semiconductor mission, you must have heard that Professor Bhattacharya has said that India's semiconductor research facility is going to come here. We have already vouched for it. Many of our friends are working in this direction. One has to think the young generation is going to be benefited, not the present generation. You have seen that we are the second largest manufacturer of mobiles in the world. And therefore, why not? We should be thinking of we will be the top manufacturers of semiconductor as well, because the amount of consumption that is going to happen in this country, because this is the second largest country in the world. Therefore, everybody is looking at India, and therefore we should take the advantage of such things and also try to utilize what we have. What we require for semiconductor mission here, as you have seen already, which Professor Bhattacharya has said and the government has already put in, you require a facility. We have been designing, fabulous design has been there in this particular institute as compared to any other institute in the country. Many of my friends do not know, they must know it. We want to have manufacturing facility. And for that, maybe at the lab level, we are trying to make an effort. We are trying to have a top class, 21st century clean room, clean facility that we have already launched. And I am very sure that in next 18 months to 2 years, a facility will exist. And therefore, there is need for the willpower of the friends. We require to have the education. You do not know that how many people required for the critical mass. We require in next 3 years of time, we require about 1,15,000 BTechs and MTechs in electronics engineering, computer engineering, electrical engineering, and so on. We require about 35,000 technicians who are diploma, BSc or MSc in these areas. We require in next 3 years about 5,000 PhDs in these areas. And who else will be doing? The IITs have to do it. And why not the first IIT of the world? Because we have the largest capacity of the faculty, friends, we have largest capacity and the infrastructure for the students as well. And therefore, I think we have to take the first lead and do it. And that is why we wanted that more and more students, I'm sure my student friends must be seeing in YouTube what has been told by the Prime Minister. Yes, we require the facilities, first we require education. So therefore, we require a critical mass. Then we require the facilities. We are going to have the facilities. And then you require the assembly testing facilities. We will be doing that assembly and test facilities at the lab level. We require at higher level, and therefore, I think many of the industries which have come across with us, they are going to help us in this manufacturing system. And I am confident that with the knowledge and the expertise that this institute has, we will be definitely line up to do the best in this regard. And we have to have, as it was very much said, that we are talking outsourced facilities. And that means we would like to also have collaboration with the universities in the world, other USA, Europe, Australia, and Taiwan, many other industries, our own industries. I think 3 of the locations which you have seen that we are going to have, 2 in Gujarat and 1 in Assam. These facilities which will be available in next 3 years of time. I think we have to take advantage of this, create the critical mass. That's why in the AI for cyber physical systems, I think we had the first cohort, we had about 1,000 students had joined for the AI. We are going to have the next cohort where we are planning to have more than 20,000 students will be online, giving them critical and short-term courses. And therefore, we are going to be launching in a very big way towards the semiconductor mission. I am confident that my friends, the faculty friends and the student friends will be coming across and help the institute as well as the nation in this endeavor. Thank you very much. Best of luck.
Thank you very much, sir. आपके वक्तव्य से मुझे विश्वास है कि आईआईटी खड़गपुर के जितने प्राध्यापक और विद्यार्थी यहाँ पर हैं, सबको अपने गंभीर उत्तरदायित्व का एहसास हुआ है। आपने अपने वक्तव्य में सही कहा कि आर्टिफिशियल इंटेलिजेंस का बहुत बड़ा तबका हमारे आईआईटी खड़गपुर का उत्पाद है। यूट्यूब में या इंटरनेट पर जितने आर्टिफिशियल इंटेलिजेंस के कोच हैं, रोहित मोटे से लेके और भी बहुत सारे, वो अधिकांश हमारे आईआईटी खड़गपुर के ही प्रोडक्ट हैं। तो मैं आप सबसे अनुरोध करूंगा कि एक बार जोरदार तालियों से निदेशक महोदय का धन्यवाद व्यक्त किया जाए इस मार्गदर्शन के लिए, इस विश्वास के लिए। निश्चित ही इस भविष्य में हमें अपना शेयर बड़ा करना है, जो कि आज हमारे सामने है। अब हम एक पैनल डिस्कशन में सहभागिता करेंगे और ये एक बहुत ही इंटरैक्टिव भी होगा। आप आज की इस पूरी संगोष्ठी के विषय में हमारे पैनलिस्ट हैं प्रोफेसर टी.के. भट्टाचार्य जी, प्रोफेसर डी.के. गोस्वामी जी, प्रोफेसर एस. मजूमदार जी, प्रोफेसर आनंदरूप भट्टाचार्य जी, प्रोफेसर मृणाल कांति मंडल जी, प्रोफेसर समीत कुमार रे, प्रोफेसर एस. दास और प्रोफेसर एस.के. वार्ष्णेय। हमारे सभी पैनलिस्ट अपने क्षेत्र के विशेषज्ञ हैं, दीर्घ अनुभवी हैं और इस पूरी परिचर्चा का व्यावहारिक धरातल पर कितना बड़ा योगदान है, कितनी महत्ता है और उसमें हमारी क्या भूमिका है, हमें वह तलाश करनी होगी। तो मैं स्कोप एंड अपॉर्चुनिटीज ऑफ आईआईटी खड़गपुर, क्योंकि आईआईटी खड़गपुर हम सब का है, जैसा कि हमारे निदेशक महोदय हमेशा कहते हैं कि ये संस्थान सबका है, हमारी सबकी इसमें बराबर की भूमिका है। तो ये मैं आमंत्रित करता हूँ अपने सभी पैनलिस्ट को कि कृपया मंच पर पधारें। जोरदार तालियों के बीच प्रोफेसर अमित पात्रा सर हमारे बीच इस प्रारंभ करेंगे, इसके मॉडरेटर हैं, और प्रोफेसर टी.के. भट्टाचार्य जी। नो टीवी, इधर से 9 चेयर्स। प्रोफेसर गोस्वामी सर, डीके गोस्वामी, प्रोफेसर मजूमदर सर, प्रोफेसर एस मजूमदर, हाँ आगे आ जाइए सर, अभी बस इंतजाम कर रहे हैं। और आनंदरूप सर हैं, मृणाल कांति मंडल सर, हाँ वो भी हैं, समित रे सर आ रहे हैं, ठीक। और प्रोफेसर एस एस दास और प्रोफेसर वार्ष्णी, हाँ ठीक। जैसा कि निदेशक महोदय ने अपने वक्तव्य में और प्रधानमंत्री ने भी अपने वक्तव्य में कहा, जैसे कि मैं देख रहा हूँ प्रोफेसर एस एस दास सर हैं GSST से। आप सभी लोग जो नए लोग होंगे या विद्यार्थी लोग शायद न जानते हों कि GSST जो आज हमारे इंस्टीट्यूट में है वो हमारे प्रोफेसर सान्याल सर के नाम पर है, और वो एक बहुत बड़े विजनरी लीडर थे, बहुत बड़े विजनरी लीडर थे, और इस IIT खड़गपुर के वो 2 बार डायरेक्टर रहे थे। आज जितनी इलेक्ट्रॉनिक्स, टेक्नोलॉजी, फिजिक्स, E&ECE डिपार्टमेंट, टेलीकम्युनिकेशन, इन सब जितनी चीज़ों को आप देख रहे हैं वो उस समय के लोगों का विजन था। तो एक छोटा सा सपना देखने की हिम्मत होती है, और वो छोटा सा सपना जब एक पौधे के रूप में, फिर एक वृक्ष के रूप में, फिर एक फूल के रूप में, फिर फलीभूत जब होता है, फल आता है, तब एक सपना पूरा होता है। वही चीज़ आज के हमारे इस दिन का टेक होम है कि जिस चीज़ से हमको भय लगता है, जिस चीज़ को हम इमेजिन कर पाते हैं, वही विजनरी होता है। तो मैं आमंत्रित कर रहा हूँ हमारे उपनिदेशक प्रोफेसर अमित पात्रा सर को, और हमारे अन्य पैनलिस्ट जो कि मैं एक बार फिर कह दूं, प्रोफेसर डी के भट्टाचार्य जी, प्रोफेसर डी के गोस्वामी, प्रोफेसर मजूमदर, प्रोफेसर आनंदरूप भट्टाचार्य जी, प्रोफेसर मंडल, प्रोफेसर रे, प्रोफेसर एस दास और प्रोफेसर वार्ष्णी। कृपया आप लोग मंच पर आएँ। इधर। और प्रोफेसर अमित पात्रा सर जो कि हमारे डिप्टी डायरेक्टर हैं, मैंने पहले भी कहा कि बहुत प्रारंभ में उन्होंने उन जैसे लोगों ने यहाँ VLSI के ज़माने से वो सपना देखा था। आज सौभाग्य का दिन है कि आज हम सेमीकंडक्टर के युग में हैं, और जैसा कि प्रधानमंत्री ने कहा कि आज देश उस जगह खड़ा है जहाँ दुनिया के गिने चुनी आर्थिक शक्तियाँ इस उत्पादन का साहस कर पाई हैं, आज देश उनमें है। हमारे पास पूरे विश्व की सबसे बड़ी युवा शक्ति है, सबसे अधिक हम इंटरनेट के प्रयोक्ता हैं, मोबाइल के नंबर 2 के प्रयोक्ता हैं, लेकिन साथ ही हमें यह भी एक ध्यान देना होगा कि हमें ताइवान से और अन्य देशों से यह भी सीखना होगा कि आज वो जहाँ खड़े हैं अपनी भाषाओं के बलबूते पर खड़े हैं। हमें हमारी भारतीय भाषाओं को भी तकनीकी के इन सभी नवीनतम संस्करणों में शामिल करने का साहस और रास्ते तलाशने होंगे, जिससे कि आज उन देशों की भाषाओं को लोग सीखते हैं। प्रौद्योगिकी के प्रयोक्ता बनने के साथ हमारे प्रयोक्ता भी हमारे देश की भाषाओं को सीखें। वही देश और वही प्रौद्योगिकी टिकेगी जहाँ की भाषाएं भी प्रौद्योगिकी के साथ साथ कदम ताल करती हुई चलेंगी। एक बार जोरदार तालियों के बीच में आमंत्रित करता हूँ हमारे उपनिदेशक प्रोफेसर पात्रा सर को आगे के सत्र संचालन के लिए। आइए सर। प्रोफेसर भट्टाचार्य सर, आप।
हेलो, गुड मॉर्निंग एवरीवन। we're a little bit behind schedule, but still, I think we'll be able to make up some time. Start with, we're still having one chair short, but in the meantime, let me call all the panelists. So let me start with Professor T.K. Bhattacharya, currently head of the Department of Electronics and Electrical Communication Engineering and also head of Advanced Technology Development Center, past professor in charge of VLSI, Advanced VLSI Design Lab, and my crime in partners in many of the earlier projects from the early 2000s, and he has been working in the devices, RF circuits, and also over National Nanotechnology Mission. Next, Professor D.K. Goswami, Department of Physics. He is also involved in the Nanotechnology Mission in a National User Group and works on devices and currently leading activity on the development of a clean room, the fab facility. Professor Subhashish Basu Majumder, head of the Center of Material Science Center, and also my PI in some of the projects that we have done in photovoltaics, battery management systems, and so he will bring in the material science and those aspects. Professor Anandaroop Bhattacharya, Department of Mechanical Engineering, and who is very much involved in the packaging and is leading one of the activities on packaging under the Indian Semiconductor Mission, and also PIs with me in many of the projects, especially related to battery management systems, thermal systems, and things like that. Professor Mrinal Kanti Mandal, Department of Electronics and Electrical Communication Engineering. He has been working in the area of devices, RF devices, and communications, and currently also leading one of the activities on in the Indian Semiconductor Mission. Professor Samit Ray, Department of Physics, one of the early workers in the area of device physics in our institute, and he works on various microfabrications, nanofabrication facilities. So Professor Samit Ray. Professor S.S. Das, current head of the GSNL School of Telecommunications, who works on 5G, 6G and beyond, and he will bring in the expertise and the expectations of our 6G community from the VLSI mission. And finally, Professor S.K. Varshney, just in time, his chair has come. And so Professor Varshney works on quantum and quantum photonics and photoelectronic circuits from the Department of Electronics and Electrical Communications Engineering. So we have a very big panel and very knowledgeable panel. So I'll have to just really try to control their time, otherwise we can probably spend the whole day. Maybe we can seek the director's permission to go for the whole day as well, in case there is a need for that. But to start with, let me start from Professor Goswami regarding his thoughts on the Indian Semiconductor Mission and what are our scope, opportunities. In fact, this is the theme of the panel discussion, that is the scope and opportunities of our institute, IIT Kharagpur, in the Indian Semiconductor Mission. So we are all looking forward to hear from our colleagues on what we do, what we are not able to do because of certain limitations, and what we can do better, and what actions we need to take. And finally, what support is needed from the institute to make these things happen. So this will be the broad theme. But in the same theme, I request that faculty with their own expertise in their niche areas, let us hear from them about what is their thought on this particular issue. So let me say what will be the structure of this. So initially, I will request each one of our colleagues to speak for 2 to 3 minutes, and if there is a end of it, if I happen to think of some questions, I'll ask them, and then we'll go over to the next person. And once all the faculty are covered, then we'll open the floor open it to the floor. So Professor Goswami, please.
Yeah, thank you, Professor Patra. It is my privilege to be part of this, illustrious, panel and to put my view in ISM. So essentially, I would like to make 2 points where I think that IIT Kharagpur can make significant impact to ISM. The first one is, as we already heard from our Honorable Prime Minister, that he laid down the foundation stone for 3 commercial fab. And but there are also provision in ISM documents itself where academic can take a significant role. So if we look at the type of fabs that today was laid down the foundation stone, there are other types of fabs also are there, so which are essentially semiconductor and compound semiconductor and silicon photonics and sensor fab. So these 3 fabs where actually academic people should be coming in, because there are a lot of R&D is required. So if you look at the strength, R&D strength of IIT Kharagpur, actually we fabricate a lot of sensors and publish many papers, hundreds of sensors we publish. But thing is that if we ask ourselves whether these sensors are really industries interested to these sensors, I would say the very few. And if you dig into the reason that why the situation of academia and industry connection is like this, then only thing that I found is that we develop things, develops devices at the lab, and what is missing is to develop a process for scale up, which actually require a academic fab in our institute, which badly missing for decades in this institute. Now, once we have a common kind of like platform, then definitely we can actually connect industry to our academic research. This is one part. Second part is ISM essentially, there is 2.5% of the total outlay in this is skilled manpower development, which is essentially 3,800 crore. So in this part, we academician has to take part of it. Here we need the PhD students, trained technician, and if we have again the academic fab, and also I would add to that with the academic fab, we also need a kind of like teaching training fab with that. So if we have these facilities in, definitely we can make it mark from IIT Kharagpur. So what are the training program that we have already under support of government? So there are many. So first one is Indian Nanoelectronics User Program Idea to Innovation, which we are already executing this program in IIT Kharagpur from 2021. And so far we have trained about 432 research scholars outside of the IIT Kharagpur at different level of training that we have provided. Besides that, we had hands-on training, which we have given about 120 research scholars outside of this, through this program. So this part we already have started in this institute, but there are other manpower training program like SMTP C2SD and SMTP C2S, like Chief to Startup. So these are the many other programs where actually we have to take part of it. So, so these are the opportunities. So just to summarize my the thought that there are 3 things we need to do. We need to have an academic fab at the institute. If we can have maybe another training fab, and with all that IIT, and based on the the strength, R&D strength that we have, we should vouch for a sensor fab in a national level sensor fab at IIT Kharagpur. Yeah, so that's my point.
Thank you, Professor Goswami. So let me move on to Professor Subhashish Basu Majumder and request him to talk about what are the challenges in we just all of us witnessed the inauguration of the mission, and it's very, very promising, and it's certainly going to make a difference to the country. But do you see that there are any challenges in terms of materials and the kind of availability of those materials in the country? Just like for our lithium-ion battery issues, India is short on lithium. So we can do a lot of research, but ultimately we may have issues with that. So in the semiconductor area, do you see any such sort of roadblocks, and what can we do to overcome them?
Actually, first I would like to thank the organizer for giving me a chance to speak. And what I have seen that in material-based research, material is at the heart of all of this device, be that quantum mission, be that energy mission, be that semicon mission. Material is the heart of all these missions. But the material research in our country, that is basically confined to preparation of material at laboratory scale and then characterize it and then publish papers. There are many exotic material, not only in material science that we develop, but also in chemistry, in metallurgical engineering, but all are in a very small level. And the quality of the material, how will it change when you upscale, that is not very well known. So the first and foremost point is that not only in a small quantity, but we will have to think of upscaling this material. So first we take the challenge, and Professor Patra was with me, Anandaroop was with me, and in some other projects, Samit was with me. So first we thought that this material-based research should be extended in the institute, and wherever the expertise is available, we will have to bring those people on board so that we can develop an end-to-end solution. And we have done from Material Science Center, in collaboration with Nanoscience and Technology, at least 2 such prototypes we have developed, and we have seen that it is possible. I prepare the material, then I upscale it, and then I make a battery cell. Then Professor Patra and his group, they made the BMS of it, and then Anandaroop helped me to package it with the thermal management system, and we develop a 16 ampere hour, 28 volt battery, lithium-ion battery, and then supply it to NSTL, and it is working fine in NSTL for their purpose. So that was the model, and I think this kind of model we'll have to follow. Not only material research, but it must be integrated. So we need an integrated approach. That is the foremost thing that why I want to put forward. Now let us come back to semicon. I am not from semiconductor background, but our center has a legacy to start working on single crystal ceramic, single crystal semiconducting material. It started well back, way back. Professor D.N. Bosch started in those days MOCVD, first of its kind in our country. So we have a legacy to work on single crystalline material and also device quality thin film. I think Material Science Center and other department as well, in physics also I know that there are some people, they work on it. So that is one area that we want to put forward. I mean, we want to develop in that, this thing. It is not only silicon, but unfortunately in our country, roughly 1 megawatt power generation needs 7 tons of silicon single crystal. And we are aiming by 2030 about 434 gigawatt of power generation. But unfortunately, we don't prepare even 1 kilogram of single crystalline quality of silicon. So we must think in that issue, and we have the technology available with us to make single crystalline silicon. Then the high power silicon carbide and gallium nitride will come, and it is extremely difficult to make single crystal wafer followed by chemical processing of those material which is required. Professor Bhattacharya has shown it for high power, high frequency semiconducting device. So we should take a lead to take it, and IIT Kharagpur can do this kind of thing, single crystal development. That is area number 1. Area number 2 is 2D materials. We have a very strong group, young faculties we have hired, and this 2D material will have to be integrated with the semiconductor mission. That is area number 2 that we want to put our things forward. Third thing, which is very close to my heart, is to generate a battery source on chip itself. So we call it that on chip power management. So you develop the lithium ion battery, mostly lithium ion battery, and give the power to the chip itself. So that will solve many of the problem of thermal management, which maybe Anandaroop will be talking about. And the fourth thing, there may be other material area which I do not know. For example, I came to know the glass and glass ceramics material. They're extremely important for packaging. Then number two is highly thermal conducting material. Aluminum nitride is one of them where we can put in. So in these four areas, I think we will grow ourselves, and it should be an integrated approach. There should be a central laboratory where all the people from different departments will come for a cause, for a device, for an end-to-end solution. So this pocketed research should be abolished in next 10 years, and let us go forward for a certain aim and bring all the people together for something which we can develop in India. And that spirit should be followed, whatever has been suggested by our Honorable Prime Minister. So that's all.
Hello. Yeah, thank you, Professor Basu Majumder, for identifying some of the gaps in our expertise in the institute, and also urging everyone to really break the silos. So that is, I think, very important for doing anything substantial, because nobody will be in today's world. Nobody has the expertise on everything. So you have to always collaborate, and so various departments, if they work together, it will certainly help us to really solve problems of national and international importance. Now I move on to Professor Varshney, who works on quantum as well as photonics. And so let me also ask him my personal doubt. I think many of us would be having the same doubt. So is there any difference between quantum and semiconductor? They are the same thing, or are they different? Maybe you can start by educating us on that, and then tell us more about what are the possibilities. I think it will be a related question of how would the semiconductor mission enhance our quantum capabilities, if at all?
Yeah, good afternoon to everyone, and thank you, Professor Patra, that I've been part of this panel. And to reply first the question that you have posed to me, whether the quantum is related to the semiconductor. So quantum is a probabilistic in nature. So that's what you had the doubt, that was on a quantum in nature, on the lighter side. And to process this information into the making realistic, to make the measurement and those things, the process, and to make it in devices, that's basically you need to have devices, whether it is in any circuit, whether it can be a waveguide, or it can be, or in case of right now what people are doing in quantum technology, let's say IBM, Google, they use the ion trap system based. Let's say in more generic, in the condensed matter physics approach, they create a qubits. So to begin with, I think to begin with, I work in area of photonic technology, where we cover from classical to the quantum domain. We do have some setup in the lab, which is onto the quantum. Those maybe would like to come and have a look. So I think this semiconductor mission, what is today, it will be really very big and major boost to all of us, because it covers from the, let's say, electronic devices to the optical device or photonic devices in general, because photonic technology is going to be poised to be multi-billion dollar kind of like industry in the 21st century. And the role of the electron as well as the photons are going to a major role, and where the photons is going to take a lead, whether you make a simple device with the LED or laser diode, or make a more complicated photonic circuit. So I believe this semiconductor mission is going to really make a major boost to make the industry, for the electronic industry as well, growth of the photonic industry in the country. And we won't be dependent into the kind of like a foreign, let's say the fabrication fabs. Generally, we always have this trouble, okay, we do the design part, but when it comes to the fabrication, so we look here and there. and we do not have that facility right now. In KGP, particularly in Kharagpur, we right now we don't have any kind of like a complete fabrication facilities. Characterization facilities, though we are in here and there into the various across the departments, multiple peoples are working on domain of photonics. So I would say that's definitely is going to help in the growth of the photonic industry, as Professor Majumder said. Material part, from the material, beginning from the material part, we make a device out of this, whether an electronic device or the photonic device further. So it's going to be a major boost for all of us. And personally for me, I would be very happy, excited that yes, in the next 1 and 2 years, so 2 years, I think already Director Sir has announced that our own clean fab facility would be here, and definitely we are going to churn out first device out of that from that facility, and as well as from the semiconductor fab facility, which is going to be established across the 3 locations in country. Thank you very much.
Yeah, thank you, Professor Varshney, and thank you also for being very short. So, yeah, for saving time. But you answered the question in a very nice way. That so it is through the photonics route that semiconductor industry is actually helped in the quantum mission as well. Yeah, thank you. So let me now move on to Professor Samit Ray. Apart from being a device physicist, I think he has a very good overview of the whole industry, and so I request him to tell us from his vantage point, what do you see about the future potential, and also I think having worked in this field over the last probably 30 years, and you have faced the challenges where Indian ecosystem was not there. So what kind of difference do you think it is going to make to the next generation?
Firstly, thank you, Professor Patra, for putting me in the panel. And of course, this is a dream coming true for me, because it's not 30 years, it's in fact 40 years. I passed my MSc in 82, and from that time itself, I was very fascinated about the semiconductors. So the first opportunity I got to go to the Subhashis Department, Material Science Center, to work with Professor D.N. Bose for my master's course. And from there onwards, there is no, I always remained in the same line. Particularly my PhD was in electronics, again in the microelectronics center. That time it was microelectronics centers, now it is a part of the electronics lab department. So IIT Kharagpur had many firsts. That is actually what I believe in the last 40 years. First microelectronics center, there are 4 microelectronics centers were created in 84. IIT Kharagpur was one of them, other being IIT Bombay, IIT Madras, IIT Delhi. So we are one of the first. The first so-called, as Subhasis said, first epitaxial growth of 3-5 semiconductor was done in the Material Science Center by Professor D.N. Bose. In fact, that was the first MOCVD set up in a country, in an institute. Similarly, when Professor Chopra was there, he also set up the first MB facility in the so-called academic institute. And I was very fortunate to work in this system for the last 35 years. And we did afterwards, after superconductor projects were over, initially it was for superconductors, high-TC superconductors. Then we did all silicon germanium quantum dot, germanium nanowire. So I can claim that IIT Kharagpur, if you talk about silicon, the brother of the silicon is the germanium. Because if you talk about any high-speed materials, the best partner with silicon will be germanium, and this is the only one facility in the country right now. We are expert in that. And in the physics department, we also had Professor H.N. Acharya. He thought about the materials from the West, the silicon from rice husk. So I was very, very fortunate to come in contact with these people. And I think with this background in mind, that IIT Kharagpur has a very strong potential to contribute to Indian semiconductor mission as well as the quantum mission. Because as Professor Varshney also said, I agree with him that one thing I like about this fab that is being done by Tata Semiconductors, the kind of technology they have chosen, 28 nanometer, that is perfect for India right now. I attended a conference in Bangalore last week, IEEE, where 40% of the company people attendees are from the companies. So they are thinking of 1 nanometer in 2030, some trillion transistor per chip. But India cannot do that right now. India cannot afford to do that right now. So there are many things, particularly for automotive electronics, telecom, consumer electronics. 28 nanometer has got huge potential. So there's no point on going to a competition for CPU, logic, and memory. So similarly, India should think of sensors, India should think of the photonics. Only one thing that I wanted to put, that we should put a lot of emphasis on materials as well. We are making a silicon fab, but we don't have a silicon crystal growth or silicon wafers available in the country. So that is this is also required for the photovoltaics. The government of India is actually mission on the solar energy mission. So both of these, we need lots of semiconductor materials in-house, whether it is a silicon carbide, gallium nitride. So since IIT Kharagpur has got a very, very good expertise across the department in materials like material science, metallurgy, physics, electronics, we should emphasize definitely materials along with a so-called clean room facility which can cater to both electronic and photonic devices fabrication. And I think potentially that we are very, very at good position right now because there are two other departments or centers like a School of Nanoscience and Technology and ATDC. We have got very, very strong overlap. So IIT Kharagpur is in a good position to make an impact in the country, particularly as an academic institute. And with huge faculty, huge students, and with the visionary leadership, I think we'll be able to contribute. Thank you so much.
Yeah. Thank you, Professor Ray. And thank you for reminding us about our glorious history. And because overall India didn't really show too much of progress in the semiconductor area, our efforts were probably, much of it went unnoticed. So I think we must always keep that in mind, and if you have been able to do so well when things were not in our favor, so now we should be able to do much better when everything, including the government funding, private funding, and the whole world ecosystem, world semiconductor supply chain is looking at India as a reliable alternative supply chain. So next, let me come to, so far we have heard from people mostly with physics and device materials background. So now let us come to some of the more please excuse me for the term, engineering, in the sense that somebody will have to really take all these devices and make things out of it. And so Professor Anandaroop Bhattacharya has been working in the area of packaging, and is also leading part of the activity on in the semiconductor mission in the packaging area. So I request him to probably, he was actually presenting, but he didn't have much time to explain. So explain, what is the role that we are expecting to play in the packaging area, and also, what are the challenges and, opportunities.
Sure. Thank you. Once again, thank you very much for giving me this opportunity. I could not complete my presentation, so I would like to just verbally paraphrase whatever was remaining. As part of this packaging initiative under India Semiconductor Mission, we have now set up a consortium, faculty consortium, across several institutes, including 13 IITs, IISc, then BITS Pilani, several NITs, etc., etc. And we currently have about a 70+ strong faculty team looking at various aspects of packaging. Packaging, as you saw, is an extremely multidisciplinary field, but definitely electrical engineers have their role, but you need mechanical, you need materials, you need chemical, and even within materials you need thermal, you need manufacturing, so on and so forth. Okay, so these 12, now what we have done is we have classified this into 12 what we call strategic research areas. So they include devices, they include materials, they include substrate, electrical testing, power electronics, to name a few, and then thermal design and technologies, 6G, and so on. Okay. So out of these 12, the whole idea is we are writing a big proposal, or it's working towards a big proposal, where we want to set up a center of excellence in each of these across the country in different IITs. I'm happy to inform that 2 out of these 12 areas are led from IIT Kharagpur, one on 6G by Professor Mrinal Mandal, and the other on thermal technologies and design by myself. We are one of the 3 institutes which are leading in 2 areas, others are either 0 or 1. Now, apart from this, this is an area where the research has to be aligned to the industry needs, and therefore getting the industry in right at the beginning and working towards them in defining the problems is of paramount importance. Otherwise, our research is going to stay enclosed in our labs and maybe journal papers. So this is where we also have formed a large industry consortium. We almost have 70 companies now. Last week there was a conference in Chandigarh, and most of the leading companies had come and participated. So the idea is that yes, the government funding will help us set up the infrastructure, but then to run this, we need the industry consortium model where the industry is going to fund the individual projects. So we have now almost a list of 70+ projects across the 12 SRAs which we have pitched to the industry. So hopefully some of these will materialize and we will be able to have a pretty vibrant packaging research center over here. Now regarding what are the opportunities, we already talked about education. Everybody's talking about research, that's important, I'll come to that as well. But education, we need to develop the manpower. Okay. So 100+ faculty consortium. So in 5 to 7 years, 500 PhD students, is that unrealistic? Possibly not. 1,500 master students, and then doing an aggressive outreach, both online, offline, along with hands-on and classroom, to train about 10,000 people over the next 5 to 7 years. I think that's not unrealistic. This is just in packaging. Semiconductor is, of course, much bigger. So that's the kind of impact we can have as an institute. Now, in terms of research, as I said, industry has to play a big role. We have to be aligned with their needs. If I look at the different, our faculty team at IIT Kharagpur is almost 15 of us in the different SRAs. 2 of them are being led from here. I think Mrinal is going to cover 6G, and I'll talk about thermal, which is mine. But apart from that, there are 3 such areas that cut across all segments. Materials. Yeah, you talked about from the devices, circuits, etc. point of view. But if you talk about packaging, the substrate, we are trying to replace organic with glass. Intel just came up with that announcement. Okay, glass substrates is one. Interconnections, copper to copper bump, hybrid bonding, going to less than 10 microns pitch for interconnects, what comes out of that device to the substrate. Okay, thermal interface materials, encapsulants, polymers. So a lot of them. And finally, not to forget, solder. I don't think we have an ideal lead-free solder formulation yet. Low temperature solders, materials has a huge role. Next one, predictive modeling and analysis. We are talking about multi-physics, multi-scale, multi-dimensional problems. Okay, this co-simulation and modeling of electrical, thermal, mechanical together is of very big importance today. And companies are really looking at us to come up with those modeling frameworks. And we are working with companies like Cadence, Siemens, E&ECE, so on, to develop this. There is one SRA. I am also part of that, though I'm not leading it. Finally, thermal. Yeah, big problem. We are generating a lot of it. We want everything in our devices. So it's going to generate, and we want them to be small. We want our cell phones to be thin, the laptops to look very stylish. So it's generating heat. How am I going to remove all that heat? Okay. So here, if you look at just the microelectronics segment, you are talking about a cell phone, 5 watts, to a server CPU, 1.5 kilowatts. And if you look at a server board with the CPU, GPU, AI accelerators, etc., it's more than a couple of kilowatts today. Okay. And then if you look at several servers in a rack and several racks in a data center, several hundred kilowatts to cool. And then what do you do with all this reject heat? Are you going to reject it to the environment? Environmentalists are not going to like it. So how can we utilize this waste heat? That's where energy comes in under India Semiconductor Mission. So a lot of possibilities, a lot of opportunities, and a lot of expertise here. I think in all these areas we are working, and several of the areas are well funded by the industry, including the small funding that I get in thermal area from several industries. So we have the launch pad to really make an impact. Thank you very much.
Thank you, Anandaroop, for highlighting the pain points of packaging. And in this context, you know, I think what Professor Tarun Bhattacharya mentioned in his presentation, that I just reminded of that. And what he said is that these days you actually have to come from the reverse end. You have to think of packaging first and then come back. So that sort of reminded me of the automotive industry. In fact, the automotive industry, the integrators actually come from there. They design the car, find where there is space, where there is going to be seat, and then come back. So maybe in future, electronics devices will also be designed this same way. Yeah. Yeah, right. Yeah. So thank you. So let me now move on to Mrinal, who is the other pillar of our semiconductor mission, and to tell us about the 6G initiative, as well as what are the challenges. He also works on RF circuits, so maybe he can give us some background about how that's going to be affected, hopefully positively, by the growth of our semiconductor facilities.
Yeah, thank you, sir, for giving me this opportunity. So let me continue in line with Professor Anandaroop Bhattacharya. So last, in fact, 1.5 years almost, we are discussing with the global leaders from the industries as well as global experts from academia. So how we can contribute to the Indian semiconductor mission. And after a series of discussions and through many webinars presented by them, so we came up with these 12 strategic research areas. So what we understood that design is one of our main points, but it will remain so. But immediately in near future, we also need to stress on the beginning and ending part. So that means the material characterization, processing, as well as the packaging and testing, so that overall it looks like a complete system which is required for any product. Now, among these 12 strategic research areas, I am representing the 6G integrated systems, so which involves any design at gigahertz frequencies, wired or wireless. And it requires not just only design engineers, we need to closely work with the material engineers as well as engineers from chemical technology. And of course, the role of RF engineers, it would become a big, it will have a big impact on it. So Professor Anandaroop Bhattacharya was discussing about the packaging, particularly 3D packaging and heterogeneous 3D packaging. So where in one single package, we may have chips from different types of semiconductor materials. For example, some of them can be from silicon, some of them are made of gallium nitride, indium phosphide, and so on. So it is going to be a completely new concept which is in coming years, and basically we call it chiplet concepts, and not just one single or two types of dielectric materials for the packaging, but there will be many different types of materials. Now, what is the difference between 6G and other SRS? So since we will be working at gigahertz frequencies, so at gigahertz frequencies the requirements are different than others. So for example, we cannot use low frequency PCB at gigahertz frequencies. We have our own PCBs. So similarly for the material characterization, packaging, testing, so we have our own setup. And regarding this India Academia Meet, so last week, in fact, I also attended that 3-day conference where 260 industry representatives from almost all the big players like Intel, IBM, Infineon, Qualcomm, they came here and they shared their views, means what they are thinking down the line in next 3 to 5 years. So based on that, in fact, we submitted a 10-page proposal, 10-page from each SRA to government. And if it is accepted, so we should have 12 research centers. And as Professor Bhattacharya said that IIT Kharagpur is expecting 2 of them, one for the 6G integrated systems and another one for the thermal and packaging. So one important part will be the skill development and manpower training, and so we need to we need to actually develop curriculum for PG and PhD students, which is required by the industry and for the Indian semiconductor mission. And we have to also develop different types of courses like certificate courses, diploma courses, and we should follow some sort of multidisciplinary approach, as I said. So all the mechanical, so all the engineers from electronics, electrical, mechanical, chemical engineers, they will work in a complete ecosystem. Yeah, so that's my view. Thank you.
Yeah, thank you, Mrinal, for nicely summarizing your initiative on the 6G integrated systems. And hopefully, we get both these centers. And good luck to both you, Anandaroop, and our institute on that. So now we come over to Professor Subhrashekhar Das. He was a little bit reluctant to join this panel, saying that I am not a man from semiconductor area. But we sort of convinced him, saying that you tell us what are the requirements as 6G engineers that you expect from our semiconductor mission. So maybe you can tell us about that.
Thank you, Professor Patra. Am I audible, I guess? So I would go back to just a few lectures back when I was asking our students that when you buy a phone, what do you look for? So they say they look for the camera, they look for the display. It's working. Hello. So when I ask my students that what do you look for when you buy a smartphone, because everybody has a smartphone almost, they say I go for the camera, they go for the display, they go for the processor, and probably the battery life. And then I ask them, if I take out the modem chipset from it, then would you buy the smartphone? Then they started thinking. So what I want to convey here is the role of communications in our everyday life. So if we take out semiconductor, and or if you take communication out of any semiconductor device, I don't know if it has any value today. So we might think of communications in terms of 6G, but communications is much beyond 6G. If you look at the lunar missions and others, it's not 6G, it's very different. So the communications is a much, much larger area which hardly can live without semiconductor, so it goes together. So when we come to such communication systems, or if we look at the most popular ones like 4G, 5G or 6G, when we name these things, these are essentially called standards. So when we look into standards, standards are made by a consortium of very, very large number of companies and academia. So why I'm mentioning this? Because the intelligence, the brain which makes these things work are communications. I mean, we can make semiconductors, but what will go into it? What circuit? So you can say that I'll make a circuit, but circuit for what? It's the signal processing, and these signal processings are for these communication systems fundamentally. So take it out, it's kind of a dead device. That's what I would say. And of course, everything is important, how you package it, or what kind of optimizations you do, what kind of energy savings you do, but the brain is communications. I mean, that's the domain that I work on. So now, when we look at contributions to these domains, we have been working in this domain for quite some time. We have been developing several algorithms, but the way these things works is like there is an agreement across the global platform where people agree on to how you run your business, not in terms of your monetary business, but your protocols, your signaling procedures. So we are good at developing signal processing methods, we are good at developing waveforms, but what we actually need now to make this a success is to work with the industry. And this particular mission gives us the right opportunity to work together. So I would say that we need to have this right from the beginning to work with the industry, and that should be a very, very critical aspect, or again we are going to miss the bus exactly in the same way as we have been doing. So you'll be doing all the business, you'll be spending all the money, you'll be kind of doing what God knows, but then we'll be left behind exactly in the same place. So when we come up with an algorithm, it should be completely aligned with what is happening with the world. So if you ask, so why can't you do it? The industry, if you look at it, that's their bread and butter. So they would never expose their so-called IPs, the IPRs, right? So when we go for 6G or whatever future standards you tell about, the most important IPRs are the signals that goes out, because that has to be agreed upon by everybody. The receivers, I can have my own IPR, you can have your own IPR, but the signal that goes out, it has to be common for everyone. Now, they would never like to share that IP with anyone. So even if we are experts, we'll be left behind, we'll be kind of doing it alone. So that is one important factor we should take into account. How can the industry and academia, this has been a challenge long back, but since India is now having this manufacturing facility, Government of India is doing it, so there is a great opportunity that there should be some mechanism brought into place where the academia is not kind of just given a set of funds, do your research, publish your work, and kind of make a chip and you display in your cupboards. I mean, they should be made an integral part of this ecosystem where you participate actively. The loop should be closed, it should not be an open-ended loop. That's one side of the story. The other aspect which I would say is that, again, from knowledge, we are not behind. But if we are in this loop, our entire education program requires a change automatically. Because when we are teaching something in the class, we are talking about algorithms or signal processing, but when you put into this device, when you put into the silicon, the transformation of the algorithms change significantly. So again, when we are having such a facility at our hand, we should also have mechanisms to have this closed loop system where our academic program also needs to be upgraded, where you upgrade the programs in terms of not simply signal processing algorithms for communications, or I mean communications with networking and everything, but also at the same time what needs to be inculcated right from the beginning towards commercial manufacturing. There is a gap. It's not just simply you find out the limits or the bounds of systems, but also what are the constraints from manufacturing. And that, of course, the third aspect which I would like to also bring out is our lab facilities. Till date, we have been kind of buying devices, components, off-the-shelf things, we have been making things. So we should also aim towards having a modem which is designed and made in India. So, I mean, if we can, even if we look at very elementary things like Wi-Fi, but that rules our everyday life. So, and it's not that we don't know the mechanisms how to design those algorithms, we need to have this bridge. So, through which we can target potentially in whatever is a feasible timeline. I mean, we should not say that in 1 year or in 2 years, because it's a very, very complicated process. Those who are in the domain of telecom, they would understand it easily. To make one modem chipset over here, the number of different specializations that are required. I'm not talking about simply silicon, I'm simply talking about the algorithm methods. It's simply large, it's simply large. And putting everything together, making a modem of our own, I'm not saying IIT Kharagpur, India as a whole, I think that would be a great achievement, and that would pave the path for the future independence in the domain of telecommunications. So we have been thinking of independence. We had physical independence, of course, economic independence, and then today it's the telecom, I mean the technology independence. So this is, I would say, the foundation stone of technology independence, which we have been talking about. And this is a great thing that has happened, and I think there are these few points which should be taken into account to make it a success for all. That's it. Thank you.
Yeah, thank you very much, bro. Finally, I come to Mr. Bhattacharya, who was, of course, our initial speaker. But I'll ask him two different types of questions. One is that in all this semiconductor mission, we don't really see any activity on the VLSI design. You know, as you know that India has made great strides in the design aspects, and whatever was keeping it down was the fabs. So while fabs are coming, I think is it not a time for us to strengthen our design capabilities so that they can cope with the new facilities? And also, what are the ways in which you feel that new business and new startups can come in this area?
So these 2 points are quite relevant in today's ISM discussions. And there is a term in industry and academia, in a very lighter note, we said that dil mange more. So if you say what is dil mange more, is it a film or something? It is the more than more. More is the predicted what will be the flow of the semiconductor development, that each 18 months the transistor size will be half. But it was thinking that maybe 10 years before that 14 nanometer will be the last. After that, designers and the semiconductors more or less hitting the wall. That is called the Moore wall. But we see in 2012 announcement from the Intel that they have already gone to 12 nanometer node. So 14, 12, 7, 5, 3, 2, 1. So this is the, Intel will now come up with 1.8 nanometer, that is 18 angstrom node. So think of the challenges of the circuits based on those ICs, which is in that node. So another change, what is I call is a dil mange more, means the more than more, is that functional integrations. That means where multiple functions are integrated on a chip. So that is very, very important now. If you look at the miniaturization of the transistor size, and other end is the integration of various functionalizations. I think that sensors like MEMS-space sensors or NIMS-space sensors, integration with the CMOS is the biggest challenge. Second one is the high power circuits, integration with the CMOS platform. Third one is the high frequency circuit, integration with the CMOS platform, along with the miniaturizations, and further lab on a chip for the biomedical and devices. So these are the more domain challenges to the researcher, to the industry, and the students. So I mainly actually focusing my 2 points to my younger generation, my future generations, our students. That one thing is that if fab will come up, it will take some time, but the process of design, that has started long back under SMDP program, Special Manpower Development Program, maybe 20 years back. Now it is known as the Chip to Startup Program, and then it is CSD, Chip to System, Chip to Startup, various design issues to be, skill sets should be made from that 2000 beyond. But IIT Kharagpur, you know that we are very much visionaries at 2000. Then our alumni especially emphasized to develop a world-class VLSI design facility. So that was the beginning in India, the VLSI design in various aspects. What are those designs? Are the power management, which was, Amit was the lead for that, RFIC, the first time the RF circuits was built here, and fortunately I was associated with that. And then formal verifications, cryptography, that is chip level, as well as the digital mixed signals and those kind of, and testing. So these are the domains where we have lot of challenges today as the node size is decreasing along with the functional integrations. So that is what I say that for the designers, the challenges are infinite. The PDK file, if I look to the industry, suppose people are working on say 4 nanometer or 3 nanometer process, PDK file, that is those are designers is not yet mature. So you have a scope to actually build a test chip and give the design to validate over that technology. So IIT and the students and the design facilities what we have this potential to take those challenges. And in this regard, I was mentioning that under this program of ISM, we are in the procurement committee of the ministry. So thousands of licenses are actually we have procured from Cadence, Synopsys, Mentor Graphics, that is now Siemens, and as well as Keysight. They have some ADS and advanced tools. Those tools will be housed in the cloud, which will be maintained by CDAC Bangalore. And there will be handholding with each universities and institute. So our case, from EC Anandaroop professor, he is actually the contact points for us with that chip in centers. And it's a one window policy that all the problems you are facing they will tackle that. Only thing you have to design and hand over the design to the chip in center, and they will, on behalf of you, will fabricate the chip. And we are thinking that 28 nanometer chip will come up, say after 4 years, from, if we call them Bharat Semiconductor Manufacturing Company, BSMC. So that is the ecosystem that is coming up. So that's why I would say that in the design, there are ample opportunities for all of us, and also in the packaging and integrations. So those are very important. I just mentioned while discussing because I was in the PLI and the DLI, that is what Prime Minister has mentioned, that in the startup ecosystems, there are two schemes, product link initiative and the design link initiative. So if you look at particular to the design link initiative, here the opportunities for the young faculty members and the students to actually make their own startup. And then MIT will give 50% as grant in aid for that, and where the scope of this committee is up to 15 crores to 100 crores. So think of it, and only you have to find a partner. 50% from your side and 50% will give the subsidy for that. Think of the opportunities that this ministry has given to the younger generation, and I will be very happy to share that in the first two startup that is come up, and just last month, Chandrasekhar ji, our Ministry of State, is in IIT Hyderabad. Two startup got fund. One of them is our very first few student from the Advanced Real Estate Lab, Asudev. They got power management and energy harvesting, those kind of design challenges, and got the funding, huge funding from the ministry. I found that in a picture that Rajiv Chandrasekhar ji is actually presenting that. So like that, why not in IIT Kharagpur? We started it, so we should have the chill to make those kind of research challenge, design challenge, and give it, industry will come to you. Even yesterday, Tectonics CTO has come, and they discussed at length how they can help us in making the test and measurements set up for the IoT platform or high frequency circuit measurements. So with this, I like to end that there are very good startup ecosystems are available. More information can be carried out if you contact me. That ChipIn is the one window like that. And another one is the Advanced VSL Lab, which is equipped with all the facilities and all the EDA tools so that you can actually design any kind of chips from power electronics to RF. So I hope that this information should be beneficial for you. Thank you.
Yeah, thank you, Mr. Runu. Thanks to all the speakers. In fact, I was thinking of asking questions, but I feel in the interest of time, it is better to leave the questions to the audience, and they are all patiently hearing. And there's a lot of thanks for the audience. Let us hear from them. Please circulate some hand mics, and please raise your hands. Yeah, Professor Siddhartha Mukhopadhyay.
Hello.
First of all, thank you. Thank you for this interesting discussion. I feel that, we are finding, I'm sitting here with the head of mechanical engineering, and we were discussing that there is perhaps one aspect of the problem that we are missing, and there's no mechanical engineer here, that Anandaroop is there, he's actually a thermal engineer. What I'm talking about is that there is an aspect of manufacturing of the machines which manufacture the chips. That is an aspect. There's a very important aspect, and there's also an aspect of automation. So we may not be able to produce all aspects of the chip, but some aspects of it, I think that's an important aspect to be addressed. We have capabilities, we have huge infrastructure, can be considered within the gamut of it. Yeah.
Anandaroop, would you like to respond to that?
Yeah, I think there is an initiative on that as well, and there are some discussions. It's just not under the packaging gamut, but there is a parallel effort under India Semiconductor Mission. Yeah, I attended 1 or 2 meetings there. I don't know where it is now, but yes, there are plans.
Yeah, Devapratim.
Many of the companies which are making chips, they are having trouble transitioning to development of softwares which should accompany those chips. For example, development of SDKs that should go along with SOCs and so on. So, what are your thoughts on that?
Yeah, actually, today is probably, today's theme is the semiconductor manufacturing itself. But I think this is another thing which our government is also thinking on the, so I think Mr. Ashwini Vaishnav actually had initiated some other missions also, where the application level, software level expertise is also getting developed. But in any case, I am a little bit unsure about why you are saying that, because as far as our understanding goes, our Indian minds, students, they are capable of bridging this gap given the opportunity. So can you be a little bit more specific where exactly you see the gap?
For example, you have to develop the software development kits which should accompany all those system on chips that we are also developing.
Yes.
So people can write firmware as per the SDKs, but the SDKs needs to be developed. So that there is no work people are not talking about that. We are talking about manufacturing the chips. But the software that should accompany that part is probably where a lot of transitioning problems between companies which wants to go to the higher end of chip making, they're having troubles.
I'm still not able to see the connection. I don't know whether Shantanu Kapat is there in the audience. He was, so I think we need to connect with more of the embedded systems group to talk about that. So this panel is really not, Professor.
One point I like to add that tool development and the software that you have mentioned is exactly in the interest of the GLI scheme. So if you can give a good solutions in the software levels, that is also getting lot of support from the ministry. So EDA tool development and using machine learning approach, these are actually contribute heavily in the ISM. So this is what you mentioned is taken care in that mission. So you can contribute in this domain.
Yeah, Prashanto.
Hello. So this question is to Mrinal or Anandaroop. You two are leading two sectors of ISM. So there are other sectors, for example, where IIT Kharagpur can play a very important role, like sensors, MEMS, devices. I would like to know, will there be any call from ISM where people can submit projects and all that?
Can I go first? Well, at least under the packaging effort, there is a group for sensors, MEMS, and I think Professor Korobi Vishwas, she's part of that. So as per, there may be separate calls, I don't know, but under the packaging effort, there is a proposal that has been put up from that SRA as well, both for infrastructure as well as 5 to 7 different projects. I don't know the details there, but yeah, I can get the details to you. And yeah, one thing I would like to add is, because there are quite a few faculty members here, if you want to join any of these strategic research area teams under this effort, please feel free, please reach out to me or Mrinal. We are always willing to have more and more team members join the team, please.
Yeah, Professor Raja Datta.
Hello. Actually, I just, someone was speaking about 6G and beyond, so there are communication beyond 6G, as I fully agree with Shubhro. One thing I would like to focus on is ISRO is sending a lot of satellites, and a lot of chips are involved in that. Now, over there, I don't know whether this semiconductor mission is trying to do something on specifically on deep space communication. And for that matter, there is one thing which, in fact, IIT Kharagpur is doing for the last 10 years is interplanetary network. So that interplanetary network also requires a certain space over there in the semiconductor industry. So maybe things are a little bit in a nascent stage till now, but maybe in future it will be very important.
Yeah, I think a lot of things are happening, but some of it is also classified. And but I don't know whether Professor Tarun would like to say anything that is there in the public domain.
Yeah, so there is a section in ISM called strategic sectors, where this kind of activities are considered, and mostly in the chip level, it is the radar capability is required. So if you have that technology, radiation hardened design is a very, very important domain for India, especially for the strategic sector. So probably the network which I talk about, the hard content, that is the hardware platform, has a challenge. So this is also taken care by ISM. It is in the strategic area sections.
No, why I'm saying is, just I'd like to add, Bangalore has an 8-meter antenna where it gets data from Mars orbiter. But it's that 8 hours window, out of that around 6 hours data which it gets, it's a waste. That's because we don't have a proper network, interplanetary network. So that's where I think India can do a lot. So that's maybe a focus which I would like to.
Yeah, actually, when the ISRO chairman had come here, he did mention this initiative and he requested our faculty to participate. In fact, I think Professor Bhattacharya, Professor Bibudatta Sahu and others, they were already working with them. But as mentioned, much of the actual technologies is classified. But yes, we know that something is happening. I think Professor Rajakumar would like to ask something.
Just to add to whatever has been answered to Professor Raja, we are already a part of, ISRO is already a part of the international network for international planetary mission. And even for our own Chandrayaan, we have used the international network for tracking our own systems and for commanding our own systems like lunar module. So this apart, I think very nicely the speaker spoke about the preparedness of IIT Kharagpur, so which has been dealt in very well, and also the opportunities for chip designing. These apart, chip designing can happen with the 3 facilities existing, or 3+1, the earlier one, existing or not existing. And these facilities themselves are or even from fabrication to factory. Therefore, in the presence of these facilities, what other opportunities we will get, and particularly our students get, is an important question. If possible, please throw some light on what kind of opportunities, like startup opportunities, ancillary industry opportunities that these facilities can throw open to our youth.
Sure, thank you. Professor Bhattacharya would like to answer that. I mean, he did attempt, he gave the ideas about PLI and DLI, about startup opportunities. So anything else you would like to add?
Actually, we can discuss, since I have given you the dhacha, that is the framework that we have in ISM platform is, I mentioned DLI, and also there is a gap funding. That is, if some faculty member thinks that the technology is TRL level 6 or above, then it should go to the market, then there is an opportunity from ISM to get the gap funding. So that is their opportunity, and also there are many venture capital. They are ready to fund this. And once you showcase that one, then the 50% will be shared from the government. So you will get, say, 50 crores, the 25 crores you can get from the market, and 25 crores grant in aid will come from the semiconductor missions. That's way you can actually flourish. And it is not only for the chip design, also for the tool developments, software, the I would say Mac layer and all the protocols, where the funds are there. Thank you.
So, yeah, Professor Pathak. In fact, I was about to ask Professor Pathak if he has any question. So, please go ahead.
Yeah, I do not have question, but just only with the observation. I'm not.
Please hold it. Please hold the mic.
Yeah. So, not a specific question, but what I have observed here is that there are a lot of opportunities that are coming up with this Indian semiconductor mission. Now, we are having our STEP as well as our research part, which now can be utilized. That day, as Professor TKV I invited, and he has seen also. Now, while I was taking a survey of our students' involvement in the new and then with the startup development type of projects, I found that our number of students with the project-oriented, startup-oriented, or that entrepreneurship or market-oriented project work are very minimal. And second thing, in our research part, that which can now, as I am very delighted to know about, there are this consortium, as Anandaroop and Mrinal has told. Now, how can we exactly bring certain ecosystem there, that their presence from the research part, which can exactly give opportunity to our students and ongoing research, so that the BTech or MTech or PhD projects directly can be brought in the design book for manufacturing of those companies. And then the step we are having, even we are having at present 127 acre of land unused. So, and then also we have got our shades and the possibilities. Now, whether certain level of manufacturing, particularly those which will be developing those instruments for instrumentation, if certain manufacturing of that can be brought, as well as we are having even 8 acres of land in Kolkata, with our 10 acres land, 1 acre only built up now. So we can have a tremendous opportunity if with this, our semiconductor mission, our capabilities are focused and they make our own policy in which way our students and research scholars or the future research project proposals will be going on. And in that, I'm happy to say that at least the present with the Indian Government of India's policy of 2019 is getting implemented with our step. Now it has created a lot of positive ecosystem for the students to take up space and then form their interdisciplinary entrepreneurship or the startup initiatives. So I hope with these experts, while thinking on this line, our STEP and research park should be kept in group. And most importantly, I'm very happy to say last 3-4 years, our research parks, infrastructure has developed a lot with our classroom, and some of you have seen already the conference and the smart classrooms which are available. So that educational dissemination, knowledge dissemination system, which are being now talked of, this can take a very good regular activities over there. So I would be very happy if the persons involved in this mission who are working, if this research park and STEP is also kept in the loop so that we can together plan some activities for our students, research scholars, and also some of our experienced staff who may be working in different laboratories, their expertise can also be utilized. Thank you very much.
No, thank you. Professor Bhattacharya is a very good suggestion. In fact, of course, this was in our mind, but so far things did not get aligned. Now that the semiconductor mission has started, I'm sure we can actually replicate. We already had a consortium in our advanced VLSI design lab, but because of different reasons, including economic issues and location of Kharagpur, we could not continue that. So maybe we can revive that, and the research park will certainly help. So is there any other question from any of the audience? Yeah, please. Please introduce yourself.
Sir, I am Nimisha. I am research scholar. I just want to ask one question that under this mission, lots of EDA tools are going to be buy, but as a research scholar, I am facing the issues that beside the place the order, we need some training also, because already AVLSI lab is already very well equipped, but then also facing some issues while accessing the tools, because there is a lack of the technical expertise present in this lab. So for that, I want that there should be training session also, continuously improvement for the students going on for this.
Yeah, actually this used to be a regular affair when the lab was new and people were not aware of the tools, but as we continued, the knowledge used to be passed on from seniors to juniors and so on. But we understand, maybe because of COVID and other that gap, you know, that passing on, this has happened everywhere else in the institute as well, including the Spring Fest, you know, the previous team has not been able to transfer the knowledge. So we understand the gap. So I think we must take some action, and have you, please approach the professor in charge of the VLSI lab. I think the companies will be, I think, happy, and Professor Bhattacharya can help. They can convince them to give the training, and in fact, we can send some of our students also for training outside as required.
Especially this chip-in program, this is a regular affair that they organize workshop and webinar to train with the new softwares or any upgradations and all. So, so I will request our professor in charge, Advanced Research Lab, to be in touch with them to make some webinar or workshop to train our younger minds for the how to handle those tools.
Yes,
so
sir.
this is also in the scope of chipping.
Thank you, sir.
Yeah, is there any other question? If not, then we can actually think of winding up, because our lamp has already got extinguished. It was programmed to work up to 12:30, and it worked successfully, but then it came up. So thanks to all the panelists for their very, very illuminating discussions and suggestions. So hopefully we'll be able to take them forward. I have made some notes, so I request others also, if they have made any notes, to pass on, or maybe elaborate whatever they have said in a couple of lines, and we have an email chain, and just pass it on that, and we'll just compile and keep it for record. Acha, who is that? Yeah, please introduce yourself.
Good afternoon to all. My name is Jagannath, third year undergraduate student of E&ECE department. So, sir, I am not here to ask anything. Like, I want to learn things from you. So, my first thing is that now the semiconductor industry is like the location of the industry. Like, they can be kept over all over India in any location. So, specifically, our government has chosen the two particular locations of Assam and another at Gujarat. So, what are your thoughts on the location of the, like in any other place, or but keeping the industry at that particular location will be a boost for the particular industry, or any geographical location on it? And I would like to ask about, till now we are very happy to have the industries, but are there any side effects for the environment on developing any particular industry on, if industry has kept a particular location now, so any side effects on the waste material which was obtained from that particular industry, does it have? And my second question is that,
okay, let us stop with the first one only, because
okay,
I could not understand the initial parts, but I understood your question is that, is there any side effect of building semiconductor industry in some part of the country, right? So maybe Professor Bhattacharya can throw some light on that. Right, okay, Sir has told us the first question, why only these three locations? So I think as we understood, these are the first three locations, and these will not be the last three, So I think let us take it positively. And then, side effects, yeah, very good point, because if there are side effects, just like, there are some apprehensions about building nuclear power plants, whether any such thing is there in the case of semiconductor industry. Yeah.
So, coming to the second question, which is pretty relevant, environmental issues. Environmental issues are quite well taken in fab design. So, you know that there is some ISO standard now available. So we actually maintain that cleanliness of the inside the clean room as well as the outside, how the nature is not affected because of the toxic chemicals and hazardous waste that will come upon. There is a ISO standard waste management which actually reduces the emission and release of surge to the water to that level where it will not contaminate our ambience. And the most important thing is the water. You can say that this is the concern, because semiconductor industry does require huge water, and whether that will be natural imbalance into it. So each semiconductor industry will get the certificate. They have to show that 75% of the water is recycled, minimum. So that is the stricture, okay? So you understand that how each drop of water is very well utilized in a semiconductor fab. And that is the way, even the neighborhood ambience has to be pristine and very clear, so that that contaminations and in the clean room is not to this level of ISO 100 or ISO 10 levels. So that is the environmental issues are well protected. Trees and all this. There are many, I can discuss that, how to make a fab and ambience, how to clear, but this is a very pertinent questions. The ambience one is very well taken care in developing the fab. And regarding your first question, I am adding that one is the tip of iceberg. India is a very big country. You do not know whether some fab will come at the neighborhood Kharagpur or not. So anytime it may come. It's the beginning. Okay? Thank you.
Yeah. So you have a second question, right? Yeah. Second question. Yeah.
Now, artificial intelligence is so much increasing now, sir. So, and we're already having few sessions, like we are having some courses as even, I've also taken that particular course of cohort 1 is completed now also. So how does what are your views on this artificial intelligence affected towards this chip development? Like from the starting to ending, artificial intelligence can help each and every, like to boost the speed and to decrease the wastage also. So what are your views on this artificial intelligence and on this our semiconductor industry?
So you got it? I think you're talking about architecture development and chip design or something like that, right? Somehow I'm not able to get your voice clearly.
AI, sir, artificial intelligence.
AI.
Artificial intelligence, okay. Artificial intelligence. Yeah, that's a very good question. Okay, okay.
So in my lectures, I actually, in the presentation I told there is a huge role of AI/ML for the semiconductor developments, because you know that in the chip design, you require at least 9 to 12 months for any circuit to implement. Digital circuit where zillions of transistors are integrated may not take much time, but in analog and RF it will take at least 9 to 12 months cycles. But every 6 months you say the new computers, new systems are coming up. So that is why all the design now will be taken care with the aid of AI/ML machine learning approach. So that this is coming in a very big way. Maybe one day the digital design will be completely in the hands of AI/ML. So the designers required only for the peripheral levels. This is one. Secondly, in the testing side, you require every test cycle, millions of transistors are checked for yield analysis. So where there is, if you can even save 1 minute, that costs millions of dollars. So AI/ML is very much actively used in this. So I am just putting up two crying issues. One is the tool design for making the circuits. Another one is the testing. Both cases, AI/ML is actively used. Okay.
Yeah, Anandaroop?
I would just like to add that that's definitely what AI can do. Now, how to do that? Right now, when you design, AI accelerators are either integrated or put on the substrate as a chiplet. Okay, so that has come sort of, brought in quite a bit of paradigm shift in the way your multi-chip modules today with CPU, GPU, memory, and accelerators. Okay, that's what is really powering our chips today. So that also has been taken care of very well. So AI/ML is going to have a profound impact on how we do things in semiconductors in both ways.
No, actually there is another angle to it. Actually, while artificial intelligence is being used for chip design, on the other hand, the use of artificial intelligence and all these ChatGPT and large language models, they are raising the expectation, the requirement, the compute requirement, and that is creating the need for fabricating more and more chips. So it is a kind of very positive feedback loop. One is raising the others. So that is one of the reasons that I think this is the right time for I mean, of course, are doing this semiconductor development because of creating the second line, supply line and all that in electronics chips. But more than that, this is also the right time, because now the demand is increasing. So this is the time to get into this business. And that's why, apart from the government of India is of course always interested in developing, but all these private players are coming up, and Tatas and other companies, they are investing. So they naturally are seeing the big picture and whatever is going to happen in the future. So the AI is going to drive the semiconductor industry in the next 2-3 decades probably. So I think we should close, because this was an extra question and everybody agreed. So thank you all. Thanks to all the audience and all the panels. Our Director Sir would like to say something, so I request him to come.
Hello. Friends, I think it was a very good interaction. See, the aim was that more and more of you should be involved in the new generation academics which is coming up. I told you that the requirement in next 3 years is of the order of 115,000 BTechs, MTechs, and about 5,000 PhDs. I think Anandaroop said about that, its possibility. And for that, I think you have to come across, irrespective of the domain. Remember that. Now, I think that's why we have taken from right 2020 that each one of you, irrespective of your domain knowledge that you are going ahead, you must have a course on AI ML, which will help you in understanding, because the next generation in 21st century, the different types of jobs and startups that you are going to take up in any field for that matter will require AI. And of course, when you talk of these devices, you will have to have idea about the semiconductors. And therefore, this particular, the panel discussion which has exposed that how much of knowledge that we have in this institute. You must know that this is just tip of the iceberg that has been told here, and the amount of work already done in VLSI for last 25 years or so. Many of the people do not know that first started at IIT Kharagpur only. And in my department, people had worked on silicon from rice husk in those 70s, and I think material science and agriculture engineering department had. So I can tell you that the legacy of the knowledge that we have at IIT Kharagpur is tremendous. And the questions, it was very nice questions asked by my students, you see. Yes, it is going to affect the environment, and accordingly, the environment has to be taken off wherever we are going to have the facilities. But I think things will change over a period of time, and more requirement will come up, and therefore, your the role of the youngsters is going to be there. You have heard the Prime Minister that these for the young generation, next 25 years are you are 25 now, and by next 25 years, you will be in the best of the facilities that you think of for anything, whether it's startups, whether you're thinking of industries, and you are talking of bigger industries and bigger manufacturing ecosystem that we will have. So I think the program which we started today was already, Professor Bhattacharya has given you what are the gamuts that we are going to have. We are going to have a center here on the semiconductor. We are going to have a center for the packaging as well, and we are also working that the details of all this must be transmitted to all the students of all the disciplines, whether you talk of materials, metallurgy. The question was asked by Professor Mukhopadhyay about how we will do machines which will create those fabs. So therefore, you can see that we say that lie begets lie, but here it is that job begets job. You will require more and more things, not only the chips. When you have to have chips, you will require the material. For that, you need to have the material, the types of materials and the variety in the materials, characterization of the materials. So much of job will be generated, so much of the semiconductor accelerators and startups, the packaging technology, all these things will come up in the future. And therefore, I think the effort that IIT Kharagpur has taken today for conducting this particular program from 9:30 to 1 o'clock now here, I am very grateful to all my faculty friends who have met this Professor Patra and all his team. I think they have taken a good step in this direction to have a panel discussion to let our friends know. Those who are here, they will know. Those who are not here, they will learn from our friends, and also it is there in the YouTube. So best of luck, friends. I hope that this will go a long way in your understanding of how and what is the depth of IIT Kharagpur and what is the contribution of IIT Kharagpur. Thank you very much.
बहुत बहुत धन्यवाद सर। और मैं पैनल के सभी विद्वान प्राध्यापकों से हमारे उपनिदेशक महोदय का हार्दिक धन्यवाद देता हूं और निवेदन करता हूं आप अपना स्थान ग्रहण करें। और मैं संस्थान के कुल सचिव कैप्टन अमित जैन सर से अनुरोध करूंगा कि वे आज के इस बहुत ही महत्वपूर्ण कार्यक्रम के धन्यवाद ज्ञापन के लिए हम सभी की ओर से संस्थान के निदेशक, प्रधानमंत्री और सभी पैनलिस्ट को आभार व्यक्त करें।
Director IIT Kharagpur, Professor Mrinal, dignitaries on stage, all who are present over here, either locally or in remote. Thank you very much for being with us on this momentous occasion. I thank you all, the AV team, the student affairs team, and the entire faculty for being so enthusiastic in participating on this occasion. Thank you very much and all the best. Thank you very much.
Thank you, sir.